Srimati R. Padmavati, Head of Department EC, Dhanalakshmi Srinivasan College of Engineering and Technology, Chennai. She pursued her Bachelor of Engineering in Electronics and Instrumentation Engineering at the National Engineering College, Kovilpatti. She then went on to work as a technical editor in Domix Technical Information Private Limited, Chennai. She then pursued her Masters of Engineering in Applied Electronics at Satyabama University, Chennai. She is currently pursuing her PhD in Anna University, Chennai. She has published several national and international journals and has attended many conferences. Her areas of interest include linear integrated circuits, digital electronics, electronic circuits, VLSI design.
Welcome to UGC lecture series BSc Electronics Honors for the subject Analog Electronics. We are going to see about clipper, series and shunt clipper, clipper with positive and negative reference voltage. Clipper is a circuit which clips off a portion of the input signal without distorting the remaining part of the alternating waveform. Depending on the orientation of the diode, the positive or negative region is clipped off. Two types of clippers are series clipper, in which the diode is in series with the load, and parallel clipper, in which the diode is in branch parallel to the load. These are the applications of the clipper and clamper. Analog television receivers and FM transmitters. The variable frequency interference can be removed by using the clamping method in television receivers and in FM transmitters. The noise peaks are limited to a specific value, above which the excessive peaks can be removed by using the clipping method. Clampers we will see in the next session. We will see the clipper now. Series negative clipper or a simple series clipper. This is the circuit of the simple series clipper where the diode is connected in series arm or series to the load. This is the load and this is the diode which is connected in series with the load. Here we have to give the input signal, which is an alternating signal, and here we are obtaining the output. We are taking the output. So, this is the series clipper. When you apply the input voltage, positive input voltage, what happens to this diode? So, here this is positive is given to the anode terminal and here negative is given to the cathode terminal. So, it is a forward biased condition for this diode, and if it is forward biased, then the diode will act as a short circuit and the input will seen across the output. Once it is a short circuit, there is no resistance across this diode, resistance is 0 and the maximum current will flow, and so the input can be seen across the output. So, whenever the input voltage is positive, the diode will become in conduction state and the input can be seen across the output. So, in the output the output is following the input. So, what happens when the input signal here is negative given to the anode terminal and positive given to the cathode terminal? This diode is in reverse biased, and if it is reverse biased, we will feel a open circuit across the diode. Instead of a diode, we will feel a open circuit because the resistance will be very high in the reverse biased condition. So, if we have a open circuit across these two terminals, then what will happen across the output? There is no output because there is no connection in between the input and the output circuit. So, output is 0. So, here there is no output is 0 here. Only for the positive half of the input signal the diode conducts and it follows the input, and for the negative half of the input signal the diode does not conduct and there is no current flow. So, the output is 0, it maintains in the 0 level, and this is for the sinusoidal waveform. These waveforms are for the square wave and triangular wave. This is the series clipper with DC supply. So, when you look after the two circuits, here only the diode is connected in series with the resistance and here with the DC supply the diode is connected in series with the resistance. So, this is the input voltage. The maximum voltage is taken as Vm, and here this DC voltage is taken as V, and positive is given to the through the supply to the anode, and negative is connected to the diode. I am sorry, the negative terminal is connected to the negative terminal of the external supply. So, here only the DC supply is included in the circuit when we compare it with the previous circuit. So, now we have to see what happens if the input voltage is positive and what happens if the input voltage is negative. Okay. So, if the input voltage is positive, the diode is in forward condition. When what happens to this DC supply? This input must be very high than this DC supply, then only the diode will become on. If the diode is on, then there is a short circuit, then the current will flow, then we will get the input across the output terminals, or the output follows the input. So, when the output will have transitions, this transition, when the output will have this transitions, we will see it from this circuit. So, here the transition level can be obtained during the ideal diode condition. What is the ideal diode condition? Vd is equal to 0 and the current Id is also equal to 0. This is the value of the voltage and the current for the ideal condition, and so we can obtain the transition level during this ideal diode condition. So, when we apply a KVL here, Vi minus V minus Vd minus Vr equal to 0. Vi minus V minus Vd minus Vr, otherwise it is taken as Vout, Vo equal to 0. Vi is the input voltage and V is the DC supply given in the circuit, and Vd is the diode voltage, and Vout, Vo is the output voltage. This is by KVL, Kirchhoff's voltage law. So, here we know that this Vd equal to 0 and Vout is equal to 0, because these are the ideal conditions. Vd is 0 and Id is 0, so Vout is equal to 0. From this equation, Vi equal to V. So, whenever the input voltage crosses this V, that is crosses the DC supply given in the circuit, then the output will have the transitions. So, this is the transition level we obtain from the circuit. Whenever this Vi crosses the DC supply, then the output will gets transited. So, here during the positive half of the cycle, this is the input waveform and this is the output waveform. This is the circuit. Now, we have to apply the input signal, and the instantaneous values of the input signal can be considered as DC values while applying in the circuit, and also we can obtain the instantaneous values of the output as DC outputs. We can consider both values as DC values, even though the input is a instantaneous input, right. So, if you consider the input as Vm, or if the input voltage is maximum positive, what happened to this diode? The diode will be in short circuit because it is more positive. So, if we give a positive value, then it will become in forward bias condition. In forward bias, it is a short circuit. Again, we can apply KVL in this for the circuit. So, while we apply a KVL, we are having Vi, the same equation, Vi minus V minus Vd minus V naught is equal to 0. This is Vout equal to 0. So, VD is short circuited. So, we neglect this VD. Vi minus V minus V out is equal to 0. So, this is neglected because it is short circuited. And what is V out now? V out is equal to Vi minus V. V out is equal to Vi minus V. What is Vi? That is your input signal, and what is V? That is the DC supply given in the circuit, and V out, VO is the output voltage. Now, we have to take the instantaneous values as DC value and substitute in this Vi. Take the value Vm of the input signal, substitute here Vm. What is V out? V out is equal to Vm minus V. That is the output voltage plotted here. This is the peak output voltage Vm minus V. So, what happens if the input voltage is V? Substitute here for Vi, substitute V, we will be getting V out is equal to V minus V, that is 0. So, at this point of V, we are getting output as 0, and after which also for the negative supply, for the negative, it is not the supply, it is the signal. For the negative signals, the output is 0. So, only for the positive signal, the forward bias condition happens and the diode will be shorted, and there is a flow of current and the output follows the input. For the reverse biased, for the negative values of the input, the diode will be reversed, the diode will be in open circuit, will act as an open circuit, and so there is no flow of current, there is no, it is an open circuit, there is no connection between the input and the output, and so the output is 0 for the negative value. So, the transition values, we see that whenever the voltage crosses this V, that is the DC supply, the output gets transited. So, if Vi is equal to V, V naught is equal to 0, that is the transition from positive to negative. But for the negative values, we know that the diode will not conduct and it will show the open circuit. So, the output is 0. So, this is the negative clipper with the positive reference, the same circuit, but with the different polarity for this DC supply. When you see this circuit, it is positive is connected to the positive terminal of the battery and negative is connected to the anode of the diode. When you see this circuit, the positive terminal of the DC supply is connected to the anode, only the polarity is reversed for this DC supply. Can you obtain the output waveform for this circuit? Here Vm, instead of Vm, we are having the value as 20 volts. So, what will happen for this circuit if you give this input signal? Again we have to consider the instantaneous values as DC values. We know that when this diode is going to be in on state, that is conduction state, and when the diode is in non-conduction state, when it is short, when it is open, we must know. So, for positive value of the input, what happens to this diode? For positive value, this diode will become short, and for negative value, this diode will become open. So, for negative value, if it is open, no connection between input output, so the output is 0, and for positive value, it will conduct. So, we must know the transition levels of the diode, then only we can know for which positive value it will conduct. So, how will you get the transition level of the clipper? Again we must apply KVL for this circuit. If you apply KVL for this circuit, what is the equation? Vi minus 5 volt. Here the polarity is reversed for this supply, right? So, it is plus, the remaining or one and the same, minus Vd minus V naught is equal to 0. So, we know that this Vd is short circuited and so it will not come here, it is 0. So, Vi plus 5 volt minus Vd V out is equal to 0. So, V out is equal to V I plus 5 volt, and here what is V out? V out is also 0 because when will you calculate the transition level of the clipper? Only during the ideal condition. Ideal condition is V d equal to 0, I d equal to 0. So, this V out is also 0. So, V I is equal to minus 5 volt. This is the transition level of the clipper. So, whenever this input voltage crosses this minus 5 volt of the minus 5 volt, then the output will get transited. So, here this is the input waveform and this is the output waveform. This is 20 volts, it is a peak voltage in the input, and this is minus 5 volt. This is the transition voltage of the clipper. We have just now we have seen. In this circuit, V I is equal to minus 5 volt, right. So, how will you obtain this voltage? We know that V naught is equal to V I minus V. V naught is equal to V I minus V. So, here we have to substitute the input voltage, instantaneous values of the input voltage. So, what is V I? It is 20. So, you have to substitute here 20 plus 5 volt, because we have the DC supply, it is reversely polarized. So, it is 20 volt plus 5 volt, it will become 25, and at this point V naught is equal to 0 volt plus 5 volt, because the input voltage is 0, it is the output voltage, the input voltage is 0. So, in the same equation if you substitute, this is 0 plus 5 volt, that is 5 volt, and so it is shifted, the output is shifted from 0 to 5 volt. So, it is shifted from 0 to 5 volt here, and after which for this negative values the output is 0, because V naught is equal to minus 5 volt plus 5 volt, it will become 0. So, if you see these two waveforms, instead of Vm you have to substitute 20, instead of this V you have to substitute minus 5, because the polarity is reversed. So, here it is minus, instead of minus V you have to give plus V. So, that is why it is V I plus V. V I is Vm now, 20 plus V, that is 25 volts. Here 0 plus V, it is 5 volts, V is 5 volt, and here 5 volt, that is minus 5. At this point the input voltage has minus 5. So, minus volt plus V, that is plus 5 volt is equal to 0. So, for these regions the output is 0. So, these are the different orientation of the diode as well as the positive or negative reference voltages in the series clipper. And next is parallel clipper. In parallel clipper, the diode is in parallel with the load. That is the difference between the series and the parallel clipper. In series, the diode is in series with the load. In parallel clipper, the diode is in parallel with the load. So, for the positive supply, for the positive signal, the diode is on. If the diode is on, it has a short circuit. So, what will happen to the output? If it has a short circuit, for this output, there is no output. Across the short circuit, there is no voltage drop, and so there is no output, the output is 0. And for the negative inputs, input values, the diode will be off. There is an open circuit. If there is an open circuit, here all the input voltages can be drawn across the output terminals. So, output terminal will follow the input voltage only when the diode is reverse biased, because the diode will get open circuit. So, the output follows the input. In series clipper, we have seen only during the forward bias the output follows the input, but in the parallel clipper only during the reverse bias the output follows the input. So, if you give a positive signal, the positive signal is get clipped off, and only for the negative signal the output follows the input. Similarly, for the triangular waveform also. So, this is a clipper, parallel clipper with the DC supply in the shunt arm. So, you have to understand the working of the diode, when the diode will be in on state and when the diode will be in off state. So, this is a triangular waveform with the peak voltage 16 to minus 16, and here the voltage DC supply is 4 volts. So, when the output will be obtained here, the diode should be in open circuit, then only the output follows the input. So, when this will be in open circuit, this has to be reverse biased. When this has to be reverse biased, how this diode will be in reverse biased? This negative terminal must be given with the positive voltage, and this positive terminal must be given with the negative voltage, but here the supply is 4, it is a positive supply 4 volts. So, you can reduce the, you can increase the voltage, input signals voltage. If you increases the input signals voltage more than this voltage, more than the voltage applied to the anode terminal, then the diode will be in a reverse biased condition, and then the diode will be in open circuit and the output can follow the input. So, if the input voltage is more positive than this voltage, this DC voltage, then the diode will be acting as a open circuit. So, similarly for the previous clipper, series clipper with the DC reference, we have to see the transition voltages and we have to see when the diode will be off and on. For the negative values of the input voltage, the output is calculated as 4 volt. For the negative voltage, V naught is equal to V is equal to 4 volt, because for the negative voltage the diode is short. See the circuit, this is a negative terminal. So, if you give negative voltage, it will be in a reverse bias, forward biased condition. It is if the input signal is negative, it will produce a forward biased condition. Forward biased condition gives you a short circuit across the diode, and the output voltage is only this 4 volt. The output voltage is 4 volt, V equal to V naught equal to 4 volt during the negative half of the input signal. The transition level is also 4 volt. How? So, in the circuit if you apply KVL, what happens? The transition voltage can be obtained during the ideal condition, Vd equal to 0, Id equal to 0. So, this voltage is 0 and this current is 0. So, Vd is 0. Now, Vi is equal to V. That by applying KVL, we will be getting Vi is equal to V, and that is equal to 4 volt. So, transition voltage is also 4 volt. And now again you consider the input voltage, instantaneous values as DC inputs, and apply the circuit, get the output. This is the input signal. The maximum voltage is 16, and this is the transition level of the clipper, 4 volt, transition level of the clipper. So, only beyond this 4 volt the output will be obtained. If you give more positive value, the diode will be in reverse condition. As I said, if you give more positive value, the diode will be in off condition, because it is a reverse biased condition. So, the diode is reverse biased, so open circuit, so the output follows the input. So, up to 4 volts it won't conduct. Beyond 4 volts if you give, then it will conduct it will be in reverse biased. So, the output follows the input. Here up to 4 it maintains 4, and after 4 it follows the input signal, again it maintains the voltage 4, it will not follow the negative value of the input signal. So, the transition level is maintained here as 4 volt. These are the summary of the clippers. So, these are the positive clippers and these are the negative clippers with various DC voltages. So, we have seen negative clippers. So, this is a simple negative clipper. This is the negative clipper with the DC reference voltage, and the reference voltage if it is reversed, and this is the circuit, and these are the corresponding waveforms. And if you reverse the diode and if you reverse the polarity, you will be obtaining the positive clipper here. If you reverse this diode like this, then it is a positive clipper. The positive side of the input signal will clipped away and only the negative side will be obtained. And if you reverse this diode and the diode with the DC reference, then again the positive side is clipped away and it is shifted to the given DC reference voltage. This is also the positive clipper with the diode reversed with the DC supply, and these are the parallel clippers. We have seen these types of clippers. Now, the parallel clippers with the diode cathode connected to the input signal, positive input signal, and the anode is grounded. This is the simple parallel clipper, and this is the parallel clipper with the DC supply, and here it is reversed DC supply. We have seen all these three. If the diode is reversed, you will be getting a positive clipped parallel clipper, but the positive signal is clipped off. And how will you obtain this kind of circuit? See here, there are two diodes in the two parallel arms. So, it is a combination of any two circuits out of these parallel clipper. This is a diode with the DC supply. See this, this diode and the DC supply, this combination is given here, and this combination, positive clipper and the negative clipper in the parallel clipper is combined together, and take this DC supply as V1 and this DC supply as V2. If V1 is greater than V2, what happens? The sum of the positive voltage and sum of the peaks of the positive and the negative is clipped off. You can orient the diode as well as you can give the polarity of the, change the polarity of the reference voltage. So, we can get the desired voltage signal at the voltage level at the output. Summary: we have seen clipper, and what is a clipper? This is a diode circuit which clips off the unwanted portion without disturbing the remaining part of the input signal, and there are different types of clippers according to the orientation of the diode as well as the reference voltages, positive clippers and negative clippers, in series and parallel clippers. Series clippers are the circuit in which the diode is in series with the load, and parallel clippers are a circuit in which the diode is in parallel with the load. In both series and parallel clippers, we can have different reference voltages along with the diode. So, if we give the difference positive or a negative DC reference voltages, according to which the signal will get shifted and then it is clipped off without disturbing the other part of the input signal. And what are the applications? We have seen it in the FM transmitter. So, these are the questions you can refresh your understanding. What is a clipper? List the types of clipper, give some applications of clipper, draw a series clipper with positive reference voltage. and in the next session we can have a glance in the clamper circuit. These are the references. Thank you.